Our last theorem we'll cover in this lesson for properties of parallel lines is perpendicular transversal theorem. So our perpendicular transversal theorem. Okay, so perpendicular lines are two lines, rays, or segments that intersect to form right angles. A perpendicular line is represented by an upside down T. So our perpendicular transversal theorem. It states in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So if we have N is perpendicular to L and L is parallel to M, then N is perpendicular to M. In our perpendicular transversal theorem, it stated that it must be in a plane. In this diagram, we'll see why. So we have our rectangular solid here, and line AC and line BD are parallel. And we notice that EC is perpendicular to line AC. And we know what it means to be perpendicular, and that forms our little right angle at the corner as well. BD cannot be perpendicular to EC because they're in opposite planes, and also they're skewed to each other so that they do not connect. Now let's end it with an example. We're going to be proving a relationship between two lines. We're given in a plane C is perpendicular to B and B is perpendicular to D and D is perpendicular to A. We want to prove that C is perpendicular to A. Well, our proof, we know that line C and D are both perpendicular to line B, so C is parallel to D because two lines perpendicular to the same line are parallel. It is given that D is perpendicular to A. Therefore, C is perpendicular to A because a line that is perpendicular to one of two parallel lines is also perpendicular to the other, which is the perpendicular transversal theorem. So this concludes our slide. If you have any questions, be sure to write them down and ask them in class tomorrow.